Welcome to Module 5, Basic Pipe Joints. You've worked with pipes, learned about materials, fittings and cutting. Now it's time to master the next vital skill, joining. Every pipe must be connected to another, and how you do that will determine the system's strength, safety, and success. In this module, I'll show you the different types of joints you'll use in plumbing, how to assemble threaded and solvent-welded joints, the purpose of fittings and how to use them correctly, and how to test your joints so you can trust them before water ever flows. This is where technique meets craftsmanship. It's not enough to connect pipes. You must do it with precision and confidence. Let's begin your journey into the world of pipe joints, the true art of making every connection count.
Before we dive in, let me show you what you're expected to walk away with from this module. By the end of Module 5, you'll be able to identify different types of pipe joints. You'll not only know their names, you'll understand their purpose and where each one is used in real-world plumbing. Explain the functions of common pipe fittings, from elbows and T's to unions and caps. You'll learn how these fittings make complex systems possible. Join pipes using threaded and solvent-welded techniques. These are the two most common methods in residential and commercial jobs, and by the time we're done, you'll be confident doing both. Use Teflon tape correctly to prevent leaks. You'll learn that leak-proofing is not about luck. It's about knowing the right steps and applying them properly. Test joints for strength and leakage, because good plumbers don't guess. They verify their work before the client ever opens a tap. These aren't just learning outcomes. They're real skills that you'll use for the rest of your plumbing career. Let's get started. Let's begin at the very core. What is a pipe joint? A pipe joint is where two pipes meet. It's the connection that allows water, gas, or waste to flow smoothly through a system. But it's more than just a connection. A good joint is strong, secure, and sealed. It prevents leaks, withstands pressure, and keeps the entire system safe. Every plumbing project, whether it's in a home, factory, or high-rise building, is only as good as its joints. Some joints are temporary, others are permanent. Some are flexible, others are rigid, and each one serves a specific purpose depending on the type of pipe, the fluid being transported, the pressure and temperature in the system. So, as a professional in training, never take joints for granted. Learn them, respect them, master them. Because if the pipe is the body, the joint is the heartbeat. There's no single way to connect pipes. That's why we have different types of pipe joints. Each type of joint is suited for a specific purpose, pipe material or pressure condition. Let's walk through the common ones you'll encounter. 1. Threaded joint. Used mainly with metal pipes like GI. The pipe end is threaded and screwed into a fitting. Easy to assemble and disassemble. Ideal for maintenance and repairs. 2. Solvent-welded. Joint. Most common with PVC pipes. A special solvent is applied to both the pipe and fitting, fusing them chemically. It creates a strong, permanent, leak-proof seal. 3. Welded joint. Used for steel pipes where pressure is high. This joint is made by heating and melting the ends together, forming a solid, permanent bond. It takes skill, but it's incredibly strong. 4. Fusion joint. Typical for PPR and HDPE pipes. The pipe and fitting are heated and pressed together to form a seamless connection. Once fused, it's as strong as the pipe itself. 5. Flanged joint. Flanged joints are used in large pipelines and equipment connections. They involve two flanges bolted together with a gasket in between. Great for areas that need frequent disassembly, like pumps or valves. Each joint has its place, and as a professional, your job is to choose wisely based on pressure, temperature, material, and accessibility. Use the right joint, and your system will hold strong. Use the wrong one, and everything could fall apart. Let's take a closer look at the threaded joint, one of the most traditional and trusted methods in plumbing. Threaded joints are made by cutting spiral grooves, called threads, into the ends of pipes and fittings. These grooves allow the pipe to be screwed into the fitting, just like a bolt into a nut. Where are they used? Threaded joints are commonly used with metal pipes, especially galvanized iron, GI, brass, and steel. You'll see them in water supply lines, compressed air systems, and even in gas pipelines. Why use threaded joints? Easy to assemble and disassemble, great for temporary or serviceable lines, no heat or welding required, just tools and sealant. They're perfect when you need a tight mechanical connection that can also be taken apart for maintenance. What to watch out for? Threaded joints can leak if the threads are poorly cut, you don't apply sealant correctly, or the pipe is over-tightened, which can crack fittings or strip threads. Always check your threads. Clean them. Wrap with Teflon tape or apply pipe joint compound. And tighten just enough, not too much. Because in threaded joints, precision beats force. Now let's talk about the most common method used for joining PVC pipes, the solvent-welded joint. And don't be fooled by the name. This isn't glue. It's a chemical process that melts and fuses the pipe and fitting together. How does it work? You apply solvent cement to both the outside of the pipe and the inside of the fitting. The solvent temporarily softens the plastic, and when you insert the pipe, it chemically bonds them into a single, solid piece. Why it's used? It's quick, it's leak-proof, it's strong, and it doesn't require heat or threads. That's why it's the go-to joint for PVC water supply lines, drainage systems, and irrigation projects. But here's what you must get right. Both surfaces must be clean and dry. The cement must be spread evenly, and the pipe must be pushed and held firmly. No gaps, no twisting after the bond. You only get one chance. Once it sets, it's permanent. If done right, a solvent-welded joint will last for decades, quietly doing its job behind the walls. But if rushed or done carelessly, it will fail fast. So take your time, be precise, and treat every joint like it matters, because it does. You've worked with pipes. Now let's talk about the parts that give those pipes direction, flexibility, and control, the pipe fittings. Pipe fittings aren't just connectors. They are the functional joints that help you build systems that work. So, what do fittings actually do? 1. Change direction. You use elbows to make turns. 90 degrees for sharp corners, 45 degrees for smoother curves. This controls how water flows. 2. Connect different lines. T's and crosses allow you to branch off to multiple fixtures, like a toilet and a sink from one supply line. 3. Change pipe size. Reducers help transition from one pipe size to another to control pressure, match fixtures, or save materials. 4. Extend a line. Couplings and sockets join two straight pieces, perfect when you need to make your line longer or repair a broken section. 5. Close off a line. Caps and plugs let you seal off the end of a pipe. Useful for pressure testing, future expansion, or safe system shutdown. Every fitting has a purpose, and as a professional you'll need to know not just what they are, but when to use them, and why. Because a pipe may carry the water, but fittings carry the system. Let's now take a closer look at some of the most common pipe fittings, and how you'll actually use them in the field. Elbow. Used to change direction in a pipeline, either 45 degrees or 90 degrees. You'll use these anytime your pipe needs to turn a corner, especially in confined spaces or to fit into walls. T. This fitting allows you to split a pipe into two directions. Perfect for sending water to two fixtures from a single line, like a kitchen sink and washing machine. Reducer joins pipes of different sizes. If your main supply line is 32 mm and your fixture takes 20 mm, you use a reducer to match them up. Coupling connects two straight pipes of the same diameter, ideal for extending a run or repairing a damaged section. Union. Similar to a coupling, but with one key difference. Unions are made to disconnect easily. You'll use these around pumps or places where maintenance is needed. Cap and plug. Used to close off a pipe end. Caps go over the end of a pipe, plugs go inside. Both are useful when testing, isolating, or capping future expansion lines. As a trainee, start recognizing these by shape and name, but more importantly, know when, why, and how to use them properly. Because in plumbing, fittings are like words in a sentence. They shape the message, get them right, and the system speaks clearly. Now let's walk through one of the most essential plumbing tasks, assembling a threaded pipe joint. This is a method you'll use often when working with galvanized iron pipes, brass, or steel, and if done right, it's strong, reliable, and serviceable. Step-by-step process. 1. Cut the threaded pipe to the required length. Measure carefully, then cut the pipe using a pipe cutter or hacksaw. Make sure the cut is clean and square. 2. Clean the pipe threads. Use a wire brush to remove any metal filings or dirt. Clean threads ensure a tight, leak-free seal. 3. Apply Teflon tape or thread sealant. Wrap Teflon tape clockwise around the male threads, 2 to 3 full turns. This helps seal the connection and prevents leaks. 4. Hand tighten the fitting. First, screw the fitting onto the pipe by hand. This ensures it aligns correctly and doesn't get cross-threaded. 5. Tighten with a pipe wrench. Once hand tight, use a wrench to tighten it further up firmly but not forcefully. Over-tightening can crack fittings or strip the threads. Once tightened, check that the fitting is aligned correctly and not stressed. Never force a joint into position. That's how leaks and failures happen. A threaded joint might look simple, but it demands patience, attention to detail, and a steady hand. Take your time, get it right, and let your work speak for you. Now it's time to assemble a solvent-welded pipe joint, most commonly used with PVC pipes. This is where precision makes the difference between a perfect permanent seal and a failed system. Step-by-step process. 1. Cut the pipe to length. Measure and mark your pipe. Use a PVC cutter or hacksaw to make a clean square cut. 2. Deburr and smooth the edges. Use a deburring tool or file to smooth out the inside and outside of the pipe end. Rough edges can prevent a good seal. 3. Dry fit to check alignment. Push the pipe into the fitting without cement to check fit and alignment. Mark the insertion depth with a pencil. This helps guide your cementing. 4. Clean both surfaces. Use a clean, dry cloth to wipe dirt, moisture or grease from the pipe and fitting. 5. Apply solvent cement. Evenly. Apply a generous, even coat of solvent cement to the pipe end and the inside of the fitting. Work quickly. The solvent dries fast. 6. Insert, twist, and hold. Push the pipe fully into the fitting while giving it a quarter turn. Hold it firmly for at least 30 seconds to ensure a strong bond. 7. Wipe off excess and let it cure. Wipe away any extra cement. Let the joint cure for 15–30 minutes before moving it, and a full 24 hours before pressure testing. Once joined, it's permanent. No second chances. That's why every step counts. Don't rush. Don't guess. Join it like you want it to last for decades, because it just might. Let's talk about something simple, but critical: Teflon tape. Also known as PTFE tape, it's that white ribbon you see wrapped around pipe threads. And let me tell you, it's not optional, it's essential. So, why do we use Teflon tape? 1. To seal the threads. Threads alone don't make a watertight seal. Teflon tape fills the tiny gaps between male and female threads, stopping leaks before they start. 2. To prevent rust and sticking, on metal pipes, Teflon acts as a barrier, preventing threads from rusting together or locking up. That means joints are easier to disassemble for maintenance. 3. To make assembly smoother. It acts like a lubricant, making the threads glide in more easily, reducing cross-threading and stress on fittings. How to apply it properly. Wrap the tape clockwise around the male threads, 2 to 3 layers. Cover the threads completely, but don't block the opening. And always wrap in the same direction the fitting turns, so the tape stays tight as you screw it in. Forget the Teflon, and you'll get leaks. Apply it poorly, and your joint will fail under pressure. But use it right, and it's one of the simplest ways to protect your work and your reputation. Now let's talk about the things that go wrong, the common pipe joint problems. Because as a plumber, you're not just here to join pipes, you're here to prevent failure. And most failures, they start with these small but deadly mistakes. Problem 1. Leaking joints. This is the #1 complaint. And the cause? Improper sealing, poorly applied solvent, bad threading, or forgetting Teflon tape altogether. A leaking joint isn't just a problem, it's a liability. It ruins walls, ceilings, and your client's trust. Problem 2. Over-tightening. Some beginners think tighter means better, but with threaded joints, over-tightening cracks fittings, strips threads, and stresses the system. You're not showing strength, you're causing damage. Problem 3. Misalignment. If the pipes don't line up correctly before joining, don't force it. Misaligned joints put stress on the connection and can break under pressure or over time. Always adjust the pipe, not the fitting. Great plumbers aren't just skilled, they're careful. They know that small errors during assembly lead to big problems later. So stay sharp. Don't rush. Double-check your work, because joints that hold are joints built with care. After all your careful cutting, sealing and tightening, you're not done yet. There's one final non-negotiable step: testing the joints for leaks. Because a joint that hasn't been tested isn't a joint you can trust. Here's how to do it right. 1. Close all outlets. Start by sealing all pipe ends and taps. You want to contain the pressure within the system. No place for the water or air to escape. 2. Fill the system with water. Slowly fill the pipe system with water, making sure all air is released. This helps you test real operating pressure. 3. Observe carefully. Once filled, visually inspect all joints. Look for any drips, moisture, or sweating. Even a tiny bead of water means the joint isn't fully sealed. 4. Apply pressure testing. Optional. For critical systems or pressurized lines, use a pressure pump to test the system above normal operating levels. This helps identify weak joints before actual use. 5. Tighten or rework if needed. If you notice any leaks, isolate the problem. You may need to retighten, reseal, or reassemble the joint. And then test again. Testing isn't extra work. It's your final signature on the job. It's how you guarantee performance and prevent costly surprises. Always test and always fix before you walk away. That's what professionals do. Now it's your turn. This is where you move from theory to practice and show what your hands can do. Your task is simple, but not easy: to assemble and test pipe joints using the methods you've just learned. Here's what you'll do. 1. Assemble a threaded joint, cut and thread a section of GI pipe. Apply Teflon tape correctly. Tighten the fitting by hand, then with a wrench. Make sure it's firm, but never forced. 2. Assemble a solvent-welded joint. Cut and deburr a PVC pipe. Apply solvent cement to both the pipe and fitting. Insert, twist, and hold. Wipe the excess. Then let it cure. 3. Perform a leak test. Seal the ends. Fill with water. Inspect every joint. No drips, no seepage. This is your proof of skill. What we're looking for: proper use of tools, clean, accurate cuts and joints, safe handling, leak-free results. This is more than a task. It's a rehearsal for the real world. Because when you get to site, no one will ask what you know. They'll look at what you've built. So work with pride, work with care, and let your hands prove your learning. You've just completed Module 5, Basic Pipe Joints. And now you carry with you one of the most important skills in the plumbing profession. Here's what you've mastered. Understanding pipe joints. You now know what a joint really is. Not just a connection, but a critical part of a working system. Knowing the joint types threaded, solvent-welded, welded, flanged, and fusion joints, you've seen their purpose, their process, and when to use each one. Applying the right techniques. You've learned to use Teflon tape, to cut cleanly, to seal properly, and to test confidently, because in plumbing, a joint isn't complete until it's tested. The joints you create aren't just parts of a system, they're your signature. They show your discipline, your attention to detail, and your commitment to quality. So, keep practicing. Use your training manual. Take your quiz. And above all, take pride in what your hands can now do. Module 6 is waiting, and so is your next level of mastery.
You've reached the end of Module 5, and I want you to remember this. A good plumber knows how to connect pipes, but a great plumber knows how to make joints that never fail. Now it's time to take what you've learned and make it real. Go back to your training manual, review each step, each joint type, each method. That book is your reference, your companion. Use it. Get into the workshop. Assemble joints, test them, troubleshoot them. Build with your hands until your confidence shows in every turn and seal. And don't skip your quiz. It's your opportunity to check your understanding, to confirm that your knowledge is sharp and complete before you move on. You've done well, but you're not done. The next level is waiting. Show up for it, prepared, practiced, and proud. See you in Module 6.